Hello guys, welcome back. And this session is about my most recent work on real-time clock. So I have made this attempt to use or configure the real-time clock in the FE310 SoC and write an HAL layer for the real-time clock because before we develop anything major, we need some clock reference. So the most or the recent changes covers three important files. One is this new rtc.rs inside the as a part of the FE310 library, and as I always make a wrapper or a HAL library which would abstract all the hardware details. So this is the library which would interact to the application binary or to the caller. So this completely abstracts the SOC below. And then I have also modified the LED blink code. So now you can compile with the feature flag with RTC or without RTC. So until now, so this alone has been the code in the LED blink binary, wherein the delay between on and off are determined by this delay function, which is good to start with. Any delay is good to test LED, and but only drawback of this is like it's very difficult to quantize this in real time because the delay is fixed, but in real time, if you ask me how many seconds or minutes, then I wouldn't be able to say that. So, and the main objective of bringing in this is to test my RTC library. So if you see here, it's the same start function. If you compile with the feature flag of RTC, then all this, so these instructions are to configure the digital IO or the GPIO to set a pin as the output that connects to the LED. However, these new instructions are to configure and set the RTC in FE310. Then the delay is a real-time delay in seconds. Okay, so that's the crux or the updates that I have bought in recently. So let's see first. So this is the most of the work is here, and so very first I have written this in RISC-V assembly. So if you are interested, you can watch the link which is highlighted above. And in the Rust, so all this hardware register addresses are created as constants or a constant pointer. Then I use that and create few functions to configure this RTC. So first of all, in FE310, the RTC runs with by default, it runs with an low frequency oscillator. However, I want the RTC to be run with a crystal source with 32.768 kilohertz crystal, so that it makes the real-time clock easy. So any tick would be equivalent to 1 second. So all this I have already covered as part of the RISC-V assembly. So these functions are I just wrote this to be used based on the need. I have written all these functions. You can go through this. and then the as a part of the HAL library. So try to set the time date, but this piece of code is incomplete, but mostly only these three functions or these four methods are the one that's called right now or used in the LED blink application, if you see here. So even the init, and then set the date and time, and then enable and wait in seconds. Okay, so these are all the methods. For anyone who is interested in writing a time library on top of this real-time ticks, feel free to do so. But as you know that on any platform, writing an time library, especially when it to be covering all the time zones and UTC, it's going to be a really hard thing. But if you're not aware, then there is something called as a chronology or cron crate in the Rust. You can have a look, which is already there, but that is part of the standard library. And since I don't include the standard library, I have just written some basic functions to be used and tested with this LED blink code. But otherwise, writing a full-fledged time and like a Linux time and with the time zone and UTC, it would be almost like reinventing the wheel, and it's a very hard thing, and it would consume a lot of time. But of course, you can also learn a lot. But I have not done that. I have just written these few basic functions and invoked this here. So you can always refer to this code. But to see how it works, I have already connected to the board with the OpenOCD, and if you want to build with RTC, future equal to so you can see the blue LED blinking on and off on the right bottom of the screen. So the off time is 2 seconds and the on time is 10 seconds. Okay, so that's the change, but you feel free to, you can develop more on top of this, just in case if you want to. Control C and so by default, if the feature flag RTC is not passed, then it's the same amount. It is for the same amount of time the LED will be on and off, and the delay is a fixed delay, but it's not something um, it's not derived from the real-time clock, so it would be difficult to, there's no it's difficult to measure. And so the main focus of using the RTC clock and testing if the RTC clock is configured and it's able to run is tested as part of this code. Okay, so go ahead and let me know if you have any questions. But I find this one, so this conditional compilation, if anyone has any other way of compiling a block of code other than using this CFG feature flag, please let me know in the comment section. So I just learned from the Stack Overflow question that you can use this not, like in the C we use hash if def and hash else. In embedded or in Rust, the equivalent is a feature flag, and if it is not of that, okay, so this is all I could find from the forum. And thank you for watching. And if you are interested in more videos like this on developing further peripherals on the RISC-V with on the embedded Rust code, please feel free to subscribe. And I have also given the link on the RISC-V assembly code where I enable the RTC on the description below. Thank you, and see you in the next session.